Today we begin chapter 9, which is probability. And in this first section, you're going to learn how to find probability of an event using the definition of probability. Now, as usual, we're going to start with some vocabulary. So go ahead and get those copied in. Okay. Now, when you're doing the experiment, that's something such as flipping a coin or rolling a number cube, which is often referred to as a die or dice. But whenever you flip that coin, you have two options. You can either get a heads or tails. So that's where sample space comes in. Sample space is saying what are the possible outcomes that you can get from that experiment. So if you flip a coin, you can get either heads or tails. If you roll a number cube, your options, you can either get a 1, 2, 3, 4, 5, or 6. So that is what sample space is. Now, often you're going to see probability written as a ratio, decimal, or percent. More than likely, it will be the first two, either a ratio, which is a fraction, or a decimal. But you have to know that it's between 0 and 1. It's always between those. Now, if, like you saw in the vocabulary, if it has a probability of 0, then it's impossible, which never happens. And then if it has a probability of 1, and we know 1 as a decimal is 1 because it's 1.0, which is 100%. But if it has a probability of 1, that means it's certain, something that always happens, which leaves everything in between. If it's about 50% or 1/2, then you say it happens about half the time. If it's less than that, then we know that it is less likely. It's less likely because it's less than half. And if it's more than half, it is more than likely to happen. More than likely. If it's more than half but less than certain. Okay. Now, we're going to start off by finding the probability for the outcome. On this first one, it says that the weather forecast shows a 40% chance of rain. It gives us the percent, but like I said, it's usually going to be, they usually want it as a fraction or decimal. So if you do have a percent, which could be used, you know that the probability is 40%. And if you was to change that to a decimal, as you know, you move the decimal 2 times to the left, which would give you 0.4. So the probability that it will rain is 4/10. Now to find the probability that it will not rain, you just subtract it from the whole. You know that there is a total of 100%, and you know rain is the 40, so when you subtract, you get 60%. And we know 60% as a decimal is 0.6 or 6/10. So in this, the probability of rain is 4/10, and the probability that it will not rain is 6/10. Now, one thing before we move on, showing how to write probability. Sometimes you're going to see it, capital P, which is probability. Then inside the parentheses is what they're asking the probability of. So probability that it will rain is written like so. Probability of rain is 4/10. So probability that it will not rain, no rain, is 6/10. So that is how you will often see it written and how we expect you to write it. All right, so I want you to take some time to find the probability of each one. Find the probability of getting red, yellow, and blue. And what I want you to do is do it as a fraction. Write the probabilities as fractions. All right. For the first one, probability of red. Hopefully you wrote it down like this. But you see that there are 2 reds out of a total of 4 spots. So you'll write it as 2/4, which does reduce to 1/2. So the probability of red is 1/2. Probability of yellow, there is 1 yellow out of a total of 4 spots, which can no longer reduce, so you just leave it as the probability is 1/4. And last, probability of blue, just like yellow, there's only 1 blue out of 4 spots, so the probability is 1/4. One way to check your work, if you add the probabilities together, they should have a sum of 1. So if you do it, 1/2 plus 1/4 plus 1/4, hopefully you remember, find your common denominator, which is 4. And this one becomes 2/4, and these stay the same, 1/4 and 1/4. So you get 2 plus 1, which is 4, over the common denominator, which stays the same, 4. 4/4 is 1 whole. So check your work by adding them together, and you should get 1 whole. Okay, on this one, it's whenever they give you the probabilities. So in this one, Raul needs 3 more classes to graduate from college. He registers late, so he may not get all the classes he needs. The table gives the probabilities of the number of courses he will be able to register for. So the question is, what is the probability that at least one of the classes will be available? So when they say at least one, that is saying 1 or more. So we're looking for these probabilities. So if you write it, probability at least, whoa, there we go, $, I like that. At least 1 is saying the probability of the first one, second one, and 3. Probability of 1 plus probability of 2 plus probability of 3. And the probability of 1, which they already give us, is 1400. Probability of 2, which they also give us, is 505 thousandths. Probability of 3 is 34 hundredths. And we want to add those numbers together. So when you add those, remember, line up your decimal, and you should get 0.985. So the probability of at least one of those classes being available is 0.985 or 985 thousandths. So in these type of problems, you're just using what they give you. So it says at least 1, so that means 1, and it also includes 2 and 3. So you're adding these numbers together. With that said, I want you to try this one. Probability that fewer than 2 of the classes will be available. And in this one, probability fewer than 2. Hopefully you got 155 thousandths. All right, next up is the next section, 9.2, experimental probability. The learner will be able to estimate probability using experimental methods. In this one, here's your vocabulary. And very important, For experimental probability, you have your number of times the event occurs over the total number of trials. So they're going to ask for something. And however many times it happens, that's what goes on the top. The total number of trials goes on the bottom. So on this first one, after 1,000 spins of a spinner, the following information was recorded. We're going to estimate the probability of the spinner landing on red. So we're looking for red. So as we just said, we know probability of red. We're looking for how many times it landed on red over the total. And they give us both. They tell us it lands on red 276 times, and it was spun 1,000 times. So that will be your total. If they don't give you the total, you just add the numbers together. But a lot of times they will give it to you in here. So a lot of y'all do have to read. Sorry to tell you. Now in this, you could leave it as a fraction and reduce it if possible, or you could turn it to a decimal, which since it's 276 thousandths, you would write it as 267 thousandths. So that will be your answer. Again, you're just putting what they asked for over the total. So on the next one, I want you to try that one out. Okay, for this one, probability of yellow as a decimal, it is 1800ths. If you did it as a fraction, it was 18 over 100, but then you reduce it to 9 over 50. But I would prefer the decimal term, which is 1800ths, which is easier to get. And up next, a researcher has been observing cars passing through traffic. Of the last 50 cars, 21 turned left, 15 turned right, 14 went straight. Estimate the probability that a car will turn right. I want you to try this one on your own first. All right, unlike the other one, they didn't give us the little chart. If you want, you can make the chart yourself, in which we know that left turn happened 21 times, right turn happened 15 times, and they went straight 14 times. And they even told us that the total was 50 cars. So when you're looking for the probability that it turned right, you should get 15 over 50, which as a decimal is 3/10. All right. If you have any questions, make sure you bring them up during class. As for now, I bid you farewell.